let's say YouTube. Okay. Hey, hi. Wow, am I lagging again? Uh, oh, hi. Yes, I'm back again. Yesterday, I was kidnapped by some alien, and I have to find teacher Tiger to help me a little bit. Hello. So as usual, we'll start at 2 p.m. sharp. Okay, so you can get some snacks, drinks, and of course your book and pens ready for the live stream. Kidnap. Well, Teacher Tiger didn't eat me yesterday. Otherwise, I would not be here. But yes, I was kidnapped by Teacher Turner, if you know, alien, really alien. Okay, fine. He ate me. Yes. Is that why he's called Tiger? I guess so. I guess so. You know where is Teacher Tiger today? He went back to the Singapore Zoo. Alright, so if you buy yourself a ticket, you can go visit Teacher Tiger in the Singapore Zoo. Okay. Can I change the video resolution to 700 because it's too blurry? You mean my camera or who saved me? No, I just revived again. It's like the sci-fi movie where you'll get eaten by the tiger, and if you have played like the games before, if you were eaten by the tiger, you can come back. You can revive at the respawn point. Okay. Oh, is it blurry? You mean my camera? Are you talking about my camera? I'm sorry. My camera is got a terrible resolution. Probably it's the internet issue. Maybe I should close my camera later. Okay, so today we will be doing angles, not only angles but also geometry. All right, so okay, so yesterday, and not really yesterday, last time I said, probably your brain cells got killed by the questions, and now you see I found a good picture for this. All right, so this is your brain cell on Monday, this is on Tuesday, and this is yesterday with teacher Tiger. And now my goal today will be turning your brains to something like this. Okay, so but hopefully the remaining part will be filled with something else, which I'll reveal the answer at the end of today's topic. Okay. Monday, your brains are all gone already. Okay, all right. My screen is blurry. What is it? Friday, sure, it will be all gone. Right. All the brain cells will be gone after Friday's live stream. Okay, so let's start today's topic. We will be doing topic 12. Okay, so if you don't know, let's turn your book to page 94, where you'll see topic 12. And this is where we're gonna start today. So let's start with angles, okay? And I'm sure everybody knows angles. What is an angle? And you all know that we have different types of angles, right? Like, for example, the acute angles, the small one, the right angle, and the obtuse angles. Okay, now these are the most basic stuff. And I hope that everybody knows about this, right? And now today we're not only doing with the basic angles, but more importantly is angles within the geometric shapes. Is the angles within the geometric shapes. Okay, so it looks easy. Yes, the first topic is not that bad. So keep in your mind that the basic angles are something that should have learned before we do this, right? And today we'll start with the angles in triangles. Now let me start with an easy question. Guys, I randomly draw a triangle. Okay, so this is a triangle. It's a random one. Now this is not random. Okay, this is a random one. So we start with, what is the sum of angles? Okay, I guess the YouTube side have to wait a little bit. Is it my internet or it's the... No, I think the WeChat. So I'm sorry, the YouTube side. All right, I'll keep going on. So actually we caught an angle outside. Do we know about the exterior angle, angle 4? Oh, has anybody learned about this? What do we know about the exterior angle? Yes, I think the YouTube side got some problem, right? So if you're on WeChat, please just follow my step. Oh, okay, yes, I think it's back. Okay, the YouTube side is back. Okay, so if you don't know this exterior angle conclusion, here is how it works. So first of all, just now y'all says the sum of the interior angle is 180 degrees, right? So we can write as angle 1 plus angle 2 plus angle 3 equal to 180 degrees. But at the same time, yes, says, well, angle 4 plus angle 3 is also 180 degrees. Right, so you see, we have two ways to get 180 degrees. Now 4 is not exactly 2, but 4, from this, you can see, we can draw a conclusion that angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 4. But then, if we take away the common thing, the common angle 3, right, we can conclude that angle 4 is actually equal to angle 1 plus angle 2, okay? So the conclusion is the exterior angle is equal to the sum of two non-adjacent angles. Or I should say in a simpler way, non-touching angle. Right, so we can see the angle 3 and angle 4, they are touching each other. Right, sorry, I know that you are mentioned. Two non-touching interior angles. Okay, so this is what we know about the exterior angle, and actually, just with the exterior angle, right, we can already solve some NMOS questions, and they are not that bad. They're not bad. They're not bad. That bad. Okay. So, for example, let's take a look at our Explore 1 question. Now, now, I know, right? Many of you don't have this habit, but it's a good thing for you to first of all label all the information you get on your diagram whenever you see a geometry question. Okay, so let's see what we have. ABC is isosceles triangle. Oh, by the way, I definitely should talk about the isosceles triangle as well as the equilateral triangle before we do this. So let's go back to my ugly diagram and take a look at the isosceles triangle. Okay, so guys, what do we know about isosceles triangles? What do we know about isosceles triangles? What are the properties of isosceles triangles? A brain not braining, we're still at the easy part. Okay, we have two equal sides. Yes, very good. Two equal sides. Now, what else? What else do we know? Two equal sides, two equal angles. Very good. The opposite angles of the two equal sides are also equal, and we call them the base angles. Right. So whenever you see isosceles triangle, you should immediately think about, wow, we have two equal sides, two equal angles. Okay. All right, sausage. I have no idea why the isosceles will be connected with the sausage. Anyway, now this is the type of triangle that have two equal sides. Now there is a special one of the isosceles triangle. That is, what if we have all three sides being equal? Then we will call it an equilateral. Right? Okay, so guys, just now I already told you that all the three sides are equal. So what do we know about the angles? What is the size of each one of the interior angle inside the equilateral triangle? Anybody? Equilateral triangle. $60 degrees. Okay. All right, so each of these will be 60 degrees. Okay. So something worth noticing. Actually, 60 degrees is a good angle. Right? It's a special angle. Whenever you see 60 degrees, you should also think about the equilateral triangle that we have here. Everybody love the equilateral triangle. At least I love it, because it has all three equal sides, right? Save a lot of time. Yes, all three angles are equal, and they are all 60 degrees. Right? Okay, so we know the isosceles triangles. We know the equilateral triangles. We also have learned about the exterior angles. Right, so let's just move on to take a look at our first question where we have an isosceles triangles. So the question have already tell us that AB equal to AC, right? So if you want to find out two base angles, it will also be the opposite angle of the base angle, which we can tell directly that B and C, they are equal. So angle B equal to angle C. Okay, that's a good thing. Now we also know that BAD is 30 degrees, which is also labeled here, right? And AE equal to AD. So let's also label this AE equal to AD. Okay? We want to find out the triangle CDE. Now is this one in degrees? Okay, it seems like we are only given one angle here. All right, it seems like we are only given one angle and we don't have enough information. But relax, because whenever you don't have enough information, you don't have enough specific values, you can try to label like some of the angles as X and Y. Right, and find a relationship between the X and Y to solve the question itself. So here in this diagram, okay, I know the brain cells are burning. So guys, let me start with the easy question. How many isosceles triangles can you find in this triangle, in this figure? How many isosceles triangles you can find in this figure? Let's see. Two, right? There are two of them, okay? So first of all, I have labeled the first one as angle B equal to angle C. This is from the first isosceles triangle, which is the big one. Right? Actually, there is another isosceles triangle here that I have also labeled two equal sides. So that's why we can also note that these two angles will be the same. And these two angles will be the same. Okay? So in this case, right, why don't we just set one of them as our X? Okay? For example, we can set this one as our X. Now, if we set this one as our X, how can we determine the size of the other angles? Let's focus on this part. All right, so here you got a figure that looks like this. Reminding me a little bit. I think we just talked about this one 5 minutes ago. What do we call this kind of angle of a triangle? What do we call this kind of angle of a triangle? Remind me a little bit. So this angle is what we call, let's see, exterior angle. Yes, exterior angle, right? And what do we know about the exterior angle? The exterior angle is the sum of the two non-adjacent angles, right? Non-adjacent angles. So that means this angle AED will be equal to x degrees, the sum of the non-adjacent angles plus the question mark, right? The x plus the question mark. Now how about this one? How about the ADE? Because ADE and AED, they are inside an isosceles triangle. Right, so we can also conclude that ADE is also x plus question mark. Okay, now what else do we know? Let's take a look at another triangle. Now we have already given some of the information. That is this one. Sorry. This one. But we are already given some of the information for this triangle. Right? So let me ask again. Look at this angle here. What do we call this angle of a triangle? What do we call this angle of a triangle? We call this one the ADC. Is actually another exterior angle of the triangle, of the blue triangle I had here, of the ABD I had here. All right, so based on the exterior angle that we learned before, we can see that ADC, sorry, it should be ADC. What am I doing? ADC will be equals to the sum of these two, which luckily we know it's 30 degrees and x degrees. Right, so we can conclude angle ADC is 30 degrees plus x degrees. But at the same time, just now what we have seen that angle ADC is also x plus question mark plus another question mark. All right, ADE is x plus question mark, so ADC is x plus 2 of the question mark. Okay, so with this equation, I'm sure that many of you can already get the answer. That's question mark equals to 15 degrees. All right, so actually, NMOS have a lot of questions like this. They have tested before. And unfortunately, you have to set some of the angles as unknown, x or y or question mark, whatever you like, right? And try to use the exterior angles or the other interior angles of the triangle to form an equation to solve. But this type of question, right? You see, what I did is I drew two different smaller triangles. I look at only part of it, right? To break down the complicated diagram into a simpler one. So while you are doing this question, you can do the same thing. That is, you focus on only part of the complicated diagram. See if you with the given information, right? What are the other angles you can find out with the numbers and the unknowns that you already know here? All right, I'm not really sure if the YouTube people are just chatting happily in the chat or listening carefully. Anyway, this will be the first question. Okay, will be the application of exterior angles. I'm sorry, it is messy. It is messy because yes, probably I should write at the bottom of the paper. All right, but your opinion will be ignored. So, oh, rating, yes. So let's do the rating for this question. Yeah. All right, from 1 to 5, what do you think about this question? Seven. Okay, 7. I'll take half of that. 3.5. 3.5. I'll take this as the average score. Oh, a lot of people says 1. Okay. Maybe I should lower by a little bit. 3. Okay. So this is the exterior angle question. All right. Now, a lot of ratings. Now, angles are not only within a triangle, but a lot of them will be the interior angles of polygons. More importantly, regular polygons. Right? So, guys, when I write down this word regular, what does regular means? I say regular pentagon, regular hexagon, a regular triangle, regular quadrilateral. Guys, what do we know about the regular figures? Actually, what do we know about the regular figures? Normal. What does normal means? Okay, yes. No, I mean, what does regular means in terms of mass, in terms of figures, regular polygons? What do we know about the regular polygons? Rectangular. So the regular polygons, they all have a very, very good property. That is, all sides are equal. Yes, very good. All sides are equal. Right. So first thing is all sides are equal. And the second thing is, well, since they have all equal sides, that means all angles will also be equal. All angles will also be equal. No, normal doesn't mean boring. Normal means nice. Because everything is equal and it will make everything simpler for us. It will make everything simpler for us. So just now we have seen about triangles, and I have shown you the regular triangles, right? Regular triangles are actually, we have a name for it, equilateral. Okay, now guys, this is 3 sides. How about 4 sides? What do we call the regular 4-sided polygon? There's a name for it. What's the name of the regular 4-sided polygon? Let's see. 90. Okay. Yes, actually, we had a simple name for it. That is called a square, right? This is the regular 4-sided polygon, okay? And of course, we have the regular pentagon and a regular hexagon. If it has 6 sides, of course, mine is probably not that regular. All right. Now, since just now we said all the angles are equal, right? So it is important for us to know how to find out the size of each of the interior angle. We know that for equilateral, that will be all 60 degrees. For square, that will be all 90 degrees. Octagon, yes. Okay. So before this, we should first of all think about how to find out the sum of all the interior angles inside a polygon. All right, so how to find out the sum of all the interior angles? Now, if you haven't learned this, find yourself a video. All right, if you have learned this, recall a little bit. How do we calculate the sum of interior angles? That will be the number of sides minus 2 and then times 180 degrees, right? So for example, if we have 3 sides, 3 minus 2 times 180, 1 times 180. This one, 2 times 180, 3 times 180, 4 times 180, right? So this is how we find out the sum of all the interior angles. And if we give it a formula, that will be, if we have n sides, then the sum of all the angles will be n minus 2 times 180 degrees. Okay, n minus 2 times 180 degrees. Okay. All right, so once we're done with this, naturally we can ask ourselves, then how can we calculate what is the size of each of the interior angle inside the regular polygon? For example, let's take a look at this regular hexagon, how can we calculate what is the size of each one of them? So here, we have to use this very good thing about the regular figure. That is, they have all the same angle, right? All the angle will be equal. All the angle will be equal. So whenever you have n sides, that means you have n angles. Right? And we know the sum of these n equal angles, they're the same, right? So that's why for each one of them, it will simply be the sum of the angles divided by the number of the angles. So this will be the general formula, right? If we talk about the regular hexagon, because we have 4 times 180, and then since we have 6 angles, so we simply divide by 6, and then we will get our final answer here. Right. Okay, so this is something that you must know, how to find out the size of each interior angle. Okay, this is something that you definitely need to know. Okay, so keep this in your mind. Let's do another example question here. Okay, that is how to find out this angle GID over here. So here we have a regular 9-sided polygon. Now, I'm not really good at calculation, I have told you before. So before we even do this question by ourselves, I want you to help me a little bit. That is, if we have 9-sided polygon, what is the size of each interior angle? Okay, let's do the calculation for me. The size of each interior angle in a 9-sided polygon would be what? Try to recall what we did earlier. Not 20. This is clearly not 20. This doesn't really look like 20. 140. Okay. 7 times 180 divided by 9, so that will be 140 degrees. Okay. So that will be 140 degrees. So that is saying all of them will be 140 degrees. Now, for this question, there are more than one way to solve. All right, there are definitely more than one way to solve. I'll just stick with an easy one. Okay, that is, we know that this angle AIH equals to 140 degrees as it's one of the interior angles. All right, so if we want to know what is the GID, which is part of the 140, now the easiest way is, well, we find out what is the size of another two, and then take them away, right? So once again, let's break down our figure into a smaller one. That is, let's focus on this triangle HIG. Okay, let's focus on this triangle HIG. So I've copied it out. I'll start with HIG. So in this triangle, we have 3 angles, HI and G. All right, we'll start with, what is the size of angle H? What is the size of angle H? That will be let's say Can anybody realize this point? Same. Okay, same. What the same means? It'll be same as the 140 that we just calculated, right? So this is 140 degrees. Okay, problem is, how can we find out the two smaller ones? How can we find out the two smaller ones? Now guys, remind yourself a little bit, what do we know of the regular figures? Not only the angles are the same, but the sides are also same, right? So if we have equal sides, HI equal to HG. So guys, what do we call this triangle HIG? What do we call this triangle HIG? We actually call it an isosceles triangle, right? Right? So isosceles triangle with the apex angle being 140 degrees. So what would be the two base angles, that is the two smaller ones? HI, angle I will be equal to angle G, which equals to how many? 40. 180 minus 40, that will be the sum of the two smaller ones, right? So each one of them will be equals to 20 degrees. Okay, task 1, we're done. This angle equal to 20 degrees. So all we left is we need to find out the angle AID, right? So this is your task number 1. So let's move on to take a look at our task number 2, angle AID. Now, how can we start with our task number 2? Once again, let's focus on the figure that contains this angle. All right, so I've drawn it out. That is this one. Now, what do we know about this figure? It's a nice, it's a nice figure because it's symmetric. So when we call things asymmetric, right? When we call things asymmetric, we should know that, like, if we fold them together, they will be the same, right? So that's, if I draw a line here, I fold the two parts together, they will be the same. So that means these two angles will also be same, right? Okay, 60. Let's see whether they're 60 or not. So some people said 60. Let's think, how did they get the answer here? All right, how did they get the answer here? Actually, look at this part of the figure. It has how many sides? It has 5 sides, right? Now just now, we've seen that every 5-sided polygon, they all have the sum of the interior angles will be equal to what? The sum of the interior angles will be equal to 3 times 180 degrees. And luckily, we do know 3 of them, right? The angle A, angle B, and angle C, they are all 140 degrees. And more importantly, the two base angles, they are the same, right? So that's why we can find out the two base angles by using the sum of all the interior angles minus 3 of the 140 degrees, the angle A, B, and C. Now this is the sum of the two base angles here. And then since we're looking for one of them, so just divide it by 2. Okay. So if you calculate this one out, yes, I'll just copy answer from Daisy, who is trying to spam the chat box with the answer. Yes, that'll be 60 degrees. Okay, so task 2, we're done. That is 60 degrees. This one is 60 degrees. Now, how about our AID? Yes, right, so AID is the whole angle AIH, 140 degrees, minus 20 minus 60. Right, so we can get this equals to 140 degrees minus 20, where we get in our task 1, minus 60, where we get it in our task 2. So what is the final answer of this? The final answer of this will be 60 degrees. Okay? So it's 60 degrees. Okay, yes, good job. So guys, this is for this question, right? So I'm using the figures that you're all very familiar with, right? The regular polygons, the isosceles triangles, and the sum of the interior angles. Right. So whenever you are doing this, the logic is simple. Break down the complicated shape into the similar ones, and we study the simpler ones first. All right. So this is what I did in this question. Okay. Rating time. Guys, let's do the rating for this question. I'll see what will be the average score you rate it for this question here. 60. Oh, sure, 60 is still talking about the answer. 5. Okay, I see a lot of 5s. But some 3s. Okay, so let's just take a middle one. All right, let's just go with 4. Actually, to me, this will be at most 3. Right. 4 or 3. Let's just go with 4. Okay, so 4 for you guys. Oh, somebody says 2. That means you are good. Okay. So this would be the topic for the angles. All right. Now, after we're done with the angles, I'm sorry, what happened? Where's my book? After we're done with our angles, so let's move on to the next topic, which is about the area and the parameter. Now, many people, a lot of you, not only you, but also some teachers, right? We have underestimated the power of formula itself. The area formula, the parameter formula, right? Formulas are the best thing we can have in geometry. Because formulas are something that people lived thousands of years ago have concluded for us that will make our life easier. Right? So let's just start with some simple shapes and try to recall what are the area formula of these. So we can start with this one, rectangle or square. All right, sure, you don't need me to teach you this one. Now, the area will be length times breadth, right? A similar figure that we can get from the rectangle, right? If you cut off this part, move it over, then what you'll get is a parallelogram. Okay, so what is the area formula of the parallelogram? Hopefully length times breadth. Length times breadth. And yes, actually it's still similar, right? It's still similar. So for the parallelogram, we can call it the base. The base as well as the height, right? So the area of this one will be base times height. Okay. Now, another one that you are very familiar with, parallelogram, is we have two pairs of parallel lines, right? But another one is the trapezium. So how do we calculate the area of the trapezium? So this time you only have one pair of parallel lines, and we call them the two bases of the trapezium. Yes, a square is a very, very special parallelogram indeed. It is. Right? So for the trapezium, the area is base 1 plus base 2, and the distance between the two bases is called the height, once again. All right, so times the height divided by 2. Okay, now these are the basic stuffs. And yes, you're absolutely correct. Right, maybe I shouldn't really ask you the question because it's not easy to type the upper bound and the lower bound. Okay, sorry, lower base. So this is the rectangles, parallelogram, and the trapeziums, right? And we also have the triangles. Well, triangles are quite easy. Everybody knows this. We have the base, we have the height. So it's the base times height divided by 2, right? So actually, most of the figures, we should try to use the area formula to calculate its area, because this is like the simplest way for us to do, and actually it's the most powerful way you'll see. Okay, so now this is the basic things we can have. Now we can have more advanced application where we will start with the area of the rectangles. Now it will give you this model. Don't know how many of you know this. All right, this model. What do we call this model? We call this one the, well, sure, I think y'all know what does the England flag looks like. All right. This is not really a half model. We'll talk about half model later. This is called an England model. Now you see, it looks like an England flag, right? So I play the FIFA football a lot. So if you play football a lot, sorry, soccer, okay, I should say, then you should be very familiar with the England model. Okay, so call this one England model. And the conclusion for the England model is A, B, C, D. We have 4 parts, right? So the conclusion is A times D will be equal to B times C. Okay, and the explanation of this one actually can do that by yourself. Just set the size to be A, B, C, D, right? And you'll see that A is A times B, B is B times D, C is A times C, and this one is C times D. So A is A times B, D is C times D, B times D, C is A times C. Right, you see, that's why they are equal, right? So this is our important conclusion. Right, so next question, I would say it's kind of the easy question we'll have today. That is, guys, take a look at this one. Ooh, a 2022 question. Okay, so for this question, actually, we have 3 unknown parts, but let me once again label the A, B, C. Right. So people, if you want to try, you can use the England model, try to find out what is A, what is B, what is C, right? Where some of them are very easy to start with. You can start with A, you can start with the B, look for the England flag, and I think you can find out the area of A and B, and then go for the C, right? So let me give you some time, maybe 1 minute. Yeah, this is easy, right? Maybe 1 minute, guys. Maybe you can first of all find out what is the area of part A, what is the area of the part B, and then go for the area of part C. Okay, we already have an answer, A equal to 20. Yes, very good. So A times All right, look for the England model. A times 16 will be equal to 8 times 10. Now, A is not really 10, 20. A is equal to, has anybody got the A correct? Similarly, you can do it for B and for C. Yeah, A is 5, right? A is just 5. Okay, and then B, right? Miao says B is 15. Okay, we can write it as 8 times B will be equal to 10 times 16. So is B 15? Calculate carefully, man. Eighty final answer. B is 20, right? B is 20. Okay, and then we can look for the C, right? So to find out C, guys, remember you cannot do like 10 times 54 equal to C times 16. Now, this ain't called an England model. This doesn't really look like an England flag, right? So to get an England flag, you have to make sure that you are talking about inside a rectangle, right? So the England model, it requires a rectangle here. So actually, what we can multiply is 10 times 54, but C times the sum of 16 and B. So that's why we find out B first. So 16 plus B, which is 20, will be 36. So we can have 36 times C will be equal to 10 times 54. So what does C equals to? Oh, you mean the answer is 40? 40 for this one? Is it 40 for this one? For the C? Okay, let me do the calculation. 540 divided by 36. I think it will be 30 here. All right, C will be 30. And hence, in total, A plus B plus C will be 5 plus 20 plus 30, 55. Okay. Well, I might have a calculation mistake. Okay, but let's see the answer. Oh, sorry. C is 20. Where did I make a calculation mistake? Oh, wait. Okay, let me check. Oh, sorry, guys. I think the solution here is, here it should be B, right? Here it should be B. And this one should be C. This one should be 16 plus B, right? So there are some mistakes here. I'm sorry, guys. Yes, there is an error here. Okay, so do make sure that you correct the error on the book. Here we have an error in the solution. Yes, please swap the B and C. Okay. So here we can still get B is 20 for sure. And so this one will be 36. This one will be 540. And yes, this should be what we get. C will be 15. Okay. So guys, please swap the B and the C. It's not correct here. Okay. So yes, so the correct answer will be 5 plus 15 plus 20 equal to 40. And indeed, I made a calculation mistake. Okay. Yes, I will. I will definitely debug this one. Okay, I will definitely debug this one. Okay. All right. So this is for the England model. All right. So oh, I forgot the rating. So guys, let's do a round of rating before we move on. Rating time. I do expect to see maybe 1 and 2 this time. Right, for the rating, 1. Okay, yeah. Okay, yeah. Why don't we let's just go with 1? Okay. 5. No, it can't be 5. 1, maybe 1 to 2. Okay, maybe 1 to 2. Okay, so so next part will be a very common question. Actually, I think tested in GEP. Now this question, all right. I think many of you can do it by yourself. You can do it by yourself. Right. So I'll give you a hint here. That is, whenever you see a lot of rectangles, a lot of squares, that they are pasted together, what you need to do is you need to look for the relationship, sorry, between the length and the breadth, and the breadth of the rectangle. Okay, how can we find out their relationship? You need to find a common line. Now, there is a line in this question that is formed by the length, but on another side, it's also formed by the breadth of the rectangle. All right, that is the line here. If you look at the line, you'll see that it's 1 times of the length. If we look from the bottom, right? If we look from the bottom, that will be 1 times of the length. But if we look from the top, that will be breadth, 3 times of the breadth. So we can get our conclusion that 1 times of the length is 3 times of the breadth. And since you already know the length, everything else would be easy for you, right? Right. So this is for the area and the parameter of this type of question. Yes, very good. So actually, when you calculate the parameter of this kind of figure, right? You can it looks like irregular, but actually you can always do the push out like this. You push out the line and make it into a regular figure, right? So this would make it a lot simpler for you. This will make a lot simpler for you, especially when you calculate that parameter. Okay. Okay, so let's stop here with our this figure, and I will say, right, why don't you, since it's already like 1 hour, I know I'm going through this with a very slow pace, so so before we go into the next part, the same height model, maybe we can take a short break. Yes, we can take a short break, right? Maybe for about 4 and 5 minutes, and let's just come back at 3 p.m. Okay, so guys, if you want to take a break, go use the toilet, just go and take a break. Yes, for coffee, that's a little bit late for coffee. Alright guys, we'll be back at 3. Okay, we'll be back at 3. Coffee and bread. That sounds like the breakfast. Okay. And oh, coffee is never late. I mean, yes, kind of. I see a lot of people, right? I see a lot of people in Singapore that they drink coffee at 9 or 10 p.m. at the coffee store. I was wondering how could they even fall asleep with that? That's actually quite late. No, beer is a different thing. By the way, don't please. Be healthy. Do not drink. I try not to drink like a lot of coffee or beers at the night. Um, I only drink coffee. I think in the morning at most before 4 p.m. at most. Otherwise, it will be too late for me. Okay, while you're talking to each other, right, chatting, let me draw the diagram for the next part, which is an application of our formula. All right. So actually, a lot of questions we're gonna do later will all just be an application of the formula, especially the formula of the triangles. So let me write down the formula of triangles here to remind you a little bit. Base times height divided by 2. Right. Oh. A, B, C, and D. What topic is this? It's the same height model. It's the same height model. Which you should have learned this one before. I think last semester, where I had a very clear memory that everybody died on this topic. Literally everybody died on this topic. Okay. Okay, so let's get started on the next part, which is the same height model. Okay. Now, as I said, it's actually same as it's just an application of our formula, because you see now I have draw a line here. I cut. I cut the bigger triangle ABC into two smaller ones, right? ABD and ACD. Now let's just say that they have a base of 1 and 2, right? So if you want to calculate the area of this, you draw the height, you'll see that for this triangle ABD and triangle ACD, they all have, now this is not topic 13, this is topic 14. This is topic 14. Yes, very good. All right, you'll see that they share same height. All right, so if you calculate the area, now that will be 1 times height divided by 2, and 2 times height divided by 2. Actually, here we can bring up our idea of the unit thing, okay? That is the area of ABD to the area of ACD will just be 1 unit to 2 units. Or make it simpler. That will be same as the ratio of the base. So it equals to 1 to 2, which is equal to the ratio of the base BD to DC. Okay? So this is the basic idea of how to use the same height model is that whenever you have a ratio of the sides, you can turn into the ratio of corresponding area of triangle. Ratio of triangle of the corresponding ratio of the area of the corresponding triangles. And also, of course, if, let's say, for example, I draw another triangle, I tell you that this is 1 unit, this is 3 units. You can actually also turn the area of the triangle back into the ratio of the sides. the ratio of the base, to be honest. So 1 to 3, so the ratio of the base will also be 1 to 3. Okay, so this topic is basically about turn the ratio of the sides to the ratio of the area. If you have the ratio of the area, turn it back to the ratio of the sides. Right. So, of course, there are a lot of another models that we can derive from the same height model. Some of you might have learned about this kite model thing, where you connect the two diagonal of a quadrilateral, right? There are a lot of conclusion that we can have for this. An important conclusion is the area of the blue triangle to the area of the red triangle. It's same as, let me label number here, A, O, and B. The area of the blue to the area of the red, it's same as the ratio of AO to BO. Alright, now for the detailed thing, I'm not gonna do it here. That's quite a lot of explanation to do here. Okay, and we can also have the butterfly model, where it's a special kite model, but with with two parallel lines. So if you could remember that this is called the butterfly model, and the most important thing is the two wings of the butterfly they are the same. The wings of the butterfly are the same. Okay. And actually, we have quite a few models. First one of them could be called a bird head model. There are 3 different types. Alright, so for example, this is one type of the bird head model. Right. It is basically saying the area of the small one to the area of the big one will be equal to this times this to this. Once again, I'm not gonna explain this in detail, okay? But if you have time, you can try to derive it by yourself by simply connecting another line. So you will have to use the same height model twice. And let me show you why it's called a bird head. Bird head. Alright, because you can take this as a head of the bird. Okay? And also another type of bird head is something that looks like this. This can also be taken as the bird head. Okay? And there is another type. Where I show you here. I show you here. Okay, so for example, this and this could be another bird head. Okay, so you see three birds. Okay. So for the bird head, for these models, if you're not familiar with these models, relax. If you are with our P5 class, we will learn that one very soon. And if you are in another grade, you can go ask our teacher for some help. Right? The proof of this is actually use the same height model multiple times. All right. There is another model which is called the swallowtail model. Also commonly tested. So I'll draw it out here. Right, the swallowtail model looks like this. Okay, it looks like this. So actually, we can also connect this. So this is the swallowtail. Okay, this is the swallowtail. Or actually, in any of the triangle, there are 3 swallowtails. For the details, you can definitely go check with our teacher. Okay, so I'm not gonna spend a lot of time on this topic, okay? Because otherwise it will just take us maybe 10 hours, 20 hours to finish all of them, which is basically not really realistic. So, so yes, please, go through all of this and try to understand what is going on here. All right. So, like I said, whenever you are given the ratio of the sides, turn this one into the ratio of the area. All right. And whenever you're given a ratio of area, turn it back to the ratio of the sides. Right. All right. A lot of people says, eyes. Okay. All right. So this will be what we have for this topic. Now this is like probably one of the most difficult topic we have here, right? So do spend a lot of time on this. Make sure that you are familiar with at least the most basic same height model. Okay, so next one is about area transformation, where it's not purely about area transformation, because there is another scary thing called the Pythagorean theory. Pythagorean theory is once again about triangles, but more importantly, it's about right angle triangles. So it states that for 3 sides of the right angle triangle, they satisfy a certain condition. That is, the sum of the square of the 2 shorter sides will be definitely equal to, the square of the hypotenuse. Alright, this one is called the hypotenuse. Maybe I'm spelling wrongly. Okay. Yes, it is easy. Actually, to use it, it is kind of easy. That, for example, the most basic group of number that you'll see is 3, 4, and 5. Okay, I'm really happy to see my students still remember this. So this is just stating that 3 square plus 4 square is actually equal to 5 square, right? And if you have learned about the Pythagorean theorem lesson, and you'll see that it is highly related to the idea of the rotation. Actually, the rotation idea is highly related to the right angles. It's highly related to the right angles. Okay? So that's why next question I show you. I'll just show you. I'm not gonna only show you how we're doing this, but more importantly, why we're doing this. Right? So let's first of all take a look at the rotation diagram. Look at the rotation diagram. There are some conditions that whenever you see it, you can try to do the rotation. Okay. So first of all, a common vertex. And secondly, 2 equal sides. Now, 2 equal sides is very, very important. So that's why whenever you see a right angle isosceles, or even just a square, right? It might be a signal for you to do the rotation. Okay. Now this is a little bit too abstract, so let's go directly to our Explore 1, where even though it looks scary, but I'll show you how to solve it within 1 minute. Okay? So in the diagram below, ADE, we have a right angle triangle. We know that the white part at the bottom at the corner is a square. And we know that AD is 5, BD is 18. Find the total area of the shaded region. So you see, in this question, what do we have? We have two separated parts, right? If you want to calculate it directly, now this will be very challenging, okay? But since we have a very special condition, same sides, a square, same sides, and in between is a right angle, all right? So that means I can actually rotate this triangle by a little bit, move it down to here, okay? So let's say I call this point G. I call this point G. So here is my question for you. I'm doing the rotation, okay? Guys, I've rotated the ADE to this red triangle. So what is the size of angle BDG? What would be the size of the angle BDG? What would be the size of the angle BDG? Let's say, yes, we're doing rotation. All right, so when you do the rotation, first of all, you are definitely not changing the figure itself. You're not changing the figure itself. 90 degrees? Yes, indeed, it's 90 degrees. Why would it be 90 degrees? So let me make the diagram a little bit more clear for you, okay? Since I'm not changing the triangle, so this angle BDG will be same as the sum of this one and this one, right? I'm just rotating it done. I'm not doing anything special. So this BDG is same as my two black angles. Now what is the sum of the two black angles? It seems like we don't know. But let me take away this. We know that this red angle is the right angle, and the three angles together, they form a straight line, they form a straight angle. Right, so that's why the sum of the two black angles is also 90 degrees. So we can conclude our BDG will be equals to 90 degrees. All right. So if we look at the new shaded area, yes, if you look at the new shaded area, which is here, right? It's now a right angle triangle with one of the sides being 18 and another side, since I have rotated down, it's not changed. It's still 5. All right, yes, so if you calculate the answer, where's the formula? You have 5 times 18 divided by 2. Answer 45. Okay, so you see, very simple question that I'm only using 2 steps to solve. Right? So remember the rotation criteria that whenever we see same sides, equal sides, and in between of them, you got a very special angle, for example, 90 degrees, another special angle, for example, 60 degrees, it's time for you to do the rotation. Okay? So this will be the answer of this question. Okay. All right. Now, in NMOS, the rotation normally comes together with a complicated idea about of the hypotenuse diagram. It is actually stated here with a very fancy word, congruence. It says all the 4 right angles here in the diagram, they are all congruent. Okay, but this is just a fancy word for saying they are all identical. So if this is your first time learning about the hypotenuse diagram, Well, let's just go and check a little bit about the diagram here. All right, a very important idea is all the four angles, all the four triangles, they are all not only similar, but identical. Not only similar, they are exactly the same. All right, that's why, as you can see, we have label. Now these sides, they will all be same. As long as you know one of them, you can find out the rest. Okay, so for the next question, um, my recommendation is, well, my recommendation is for the challenge questions, all right, guys, and some of them might use a very difficult way to do the rotation, all right? So, like I said, if you don't have any idea, scan the QR code, take a look at what the teacher Turner taught you in the video explanation. Okay, so this is for the rotation part. Now I'm thinking that probably I should speed up a little bit, but next part is the fun part, which is called the half area model, right? Now, people who are in my class knows that I love to give names to the half area models. I give names to a lot of them, right, to help you better memorize them. So the idea of the half area model actually, all right, actually should come after the idea of the next topic, which is triangle with same base. Actually, same area, triangle with same area. Triangles with same area. Okay. Now we should definitely do this one first. Before we look at the half area model. So that's why, all right, guys, let's follow my step. We are going to do topic 17 first before we do the topic 16, all right? Because for some of the explanation in topic 16, I do need a little bit help from the topic 17. So what does triangle with same height means? Not triangle with same height, triangle with same area. Same area. All right. The story starts with a set of parallel lines. Okay. So guys, if this line 1 and the line 2, they are parallel, what do we know about parallel lines? Let me give you a more specific question. What do we know about the distance between the parallel lines? So if I take my ruler, measure it here, I measure the distance between two of them, right? What do we know about the distance I measure here? So this is yes, the distance is always equal, right? This is a prerequisite. Yes, first of all, we know that L1 and L2, they will never meet each other. And the good thing is, no matter where I'm using my ruler to measure the distance between two of them, the distance is definitely fixed. Right, so that's why whenever we see parallel lines, we can have the triangle with same area. Now, teacher in China, I think they call this one something like closing the curtain or something like this. All right, but we'll make it simpler. Let me first explain why we can have this conclusion. Why we can have the conclusion that the triangles, they all have the same area. Okay. So first of all, look at the two triangles I have here, the black triangle and the red triangle. What do we notice is when I draw them, I intentionally draw them to have the exactly the same base, right? I intentionally to have the base to be the same, exactly the same line. And now if we think about the area formula once again. Yes, very good. All right. So if you want to calculate the area of two of them, you draw the height. You'll see that the black height and the red height, they're all the distance between the two lines. They're all the distance between two lines. So they actually have same base and equal height. I like to say same base and equal height, not simply same base and height. Equal means, well, they could be different. The positions are different, but the values are the same, right? So whenever you have same base, equal height, if you use the area formula to do the calculation, you'll see that the area will definitely be the same, right? So we can have our conclusion that they have the same area. So actually, as long as I have the base being fixed, no matter how I move, right? Guys, take a look at what am I doing. No matter how I move the vertex along the non-parallel line, right? They still have the same base, they still have the equal height. So that's why no matter how I drag this, no matter how this changes, as long as it's still on the parallel line, we can see, well, all of them have a same area. Okay, so I really like the function we have here. Okay. But you see, when I was talking about this, where was our story starts? We always start with parallel lines. Right? We always start with parallel lines. So if you want to use the conclusion that we have here, identify the parallel lines now becomes your first priority. You must have identified the parallel lines before you can use the conclusion of the same base and the equal height. Okay, so guys, I know that you are waiting for this moment for a long time. Can y'all just type in the chat, tell me some of the figures that contains a set of parallel lines? What kind of figures contains parallel lines? What figure that has parallel lines? Okay, let's see what can you give. Actually, earlier I've mentioned some of them. Okay, trapezium, yes, square. Let's start with the rectangle, or more specifically, square. All right, trapezium, okay, they do have a set of parallel lines. What else? Rectangles, yes, rectangles. Squares, rhombus, yes, rhombus, indeed. Or we can be more general, it says equilateral, parallelogram, right? Be more general, all the parallelograms have. Rhombus is just a very special kind of parallelogram. Okay, I'll say that's all. Right. For the most common types. So identify the power lines will be the key in this topic. So if you turn your book to 145, right? A very, very common type of question is like this, right? We have a fun name for it. It's called the brother squares. We call them the brother square. So you have a bigger brother, a bigger square, together with a younger brother, a smaller square, right? So whenever you get brother squares, okay, there are quite a lot of parallel lines that you can use, okay? because we know that there are many parallel lines in the squares, right? For example, the vertical ones, okay, these is definitely parallel to each other. The horizontal ones also parallel to each other. All right, so let me first note it down. The vertical parallel lines, the horizontal parallel lines, or actually there is another group of parallel lines. Anybody realize, find out what is another group of parallel lines? Is another group of parallel lines? The diagonal, yes, very good. All right, so actually if I connect the diagonals, you guys take a look, let me use a sticker. Take a look at the diagonals, because they all have a same, they are slanted by a same degree, 45 degree. All right, so that's why we can conclude they are also parallel. They're also parallel. Yes. Well, a lot of people. Why we have people spamming the chat box with the parallel lines? Okay, so this is also a parallel set of parallel line, and actually it's like the most commonly tested set of parallel line in the brother squares. All right, so first of all, we will see how to use the parallel lines we have to derive the area of the shaded. Okay, so we start with an easy example. Let me just draw another diagram to show you another example. Okay, an easy one. That is a one that looks like this. Okay, so guys, let's focus on my diagram. Now, if I want to find out the area of this, right? So it seems like it's not that easy, right? It's not that easy. Oh, parallel is not parallel. Where is the spelling mistake? I don't see it. Anyway, if we are trying to find out this triangle, right? It is yes, very good. It is not that easy, but as long as you connect the diagonals, you will see that our shaded triangle have one of the sides is on one line and have the vertex is on another line, right? So in this case, we can just shift this vertex along the line to here, and it will be the same, okay? So if you have understand how to use the same base equal height thing, but you find this one a little bit difficult to tell, you can rotate your screen a little bit if you are using iPad, but if you are using a laptop, a desktop, you're using a PC, well, unfortunately, guys, you have to rotate your head by a little bit, okay? So we have two parallel lines. Now, based on what we have learned, we can tell that the red triangle is same as that blue triangle, okay? So it's basically half of the smaller one. Yes, so now with this easy example here, right? I'm gonna how to solve the example question itself, which is just one more step. So if we take a look at this figure, it's an irregular figure, right? So we cannot handle this one directly, right? So that's why we can kindly think about cut this one into two parts, right? So we do the same height, we do the same base, equal height thing. We do the operation multiple times to turn it into a figure that we are familiar with. Actually, guys, let me give you a hint. By looking at these two figures, okay, how can you turn the shaded area in our actual question into the red triangle I showed you earlier? How can we turn the shaded area into the right triangle I showed you earlier? Oh. So all we need to do is to identify, yes, same height, same base. Actually, is we use the vertical parallel lines. All right, so if you look at the vertical parallel lines, we actually cut the shaded area into two parts. For the left-hand side, we can just shift the A to D, and then our shaded area will be same as the red triangle I showed you earlier, right? So, and then all you need to do is just shift again, and the final answer will be half of the small square. Half of the small square. So in this question, that'll be half times 12 squared, and you can get the answer. Okay. 3 is the diagonals. Alright, so yes, if you don't understand, I do recommend you to start with even simpler figures. Okay, even simpler figures. For example, for example, if I draw something like this, and you have a triangle that looks like this, right? And then you see you have the parallel lines, so you can shifting the corner of the triangle to the corner of the square, and hence what you get is the red triangle is same as the blue triangle. So yes, if you got confused here, because you see, this is like we do need a lot of more warm-ups to get to this point, right? So if you have never learned this one before, let's just start with a set of parallel lines. We start with something that is easy. Okay, you can draw some easy diagram for yourself. You start with the easy diagram, and also take a look at the knowledge point. Hopefully that will help you a little bit. Okay, so the answer for this question will be 72. Okay, all right, so oh, I forgot to do the rating for last question, but let's do the rating here. Right. What would you rate for this question? Always remember, identify the parallel lines is the key in this topic, right? Let's say 3. Okay, 3. Reasonable. But if you have done enough question, right? 99. If you have done enough question, that should become a level 1 question for you. Okay, 3. All right, so I guess the average score we have is 3. The average, I'm just saying the average. Okay, I mean, yes, the concept itself is not that straightforward, right? So probably you do need some time to digest what we have done in this question. Okay, all right. So yeah, you see here we got some like really good diagrams. All right, so if you are confused with the explanation we had just now, you can take a look at the diagram once again to see what is going on in this question. Okay, and now for the remaining time, for the remaining like 10, 15 to 20 minutes, all right, I would say let's just go to our fun part, the half area triangles. Sorry, the half area models. Okay, now I'm sure that you all understand what this half means, right? So I always like to start with an easy half. Actually, just now we have already seen a half. Now, if you connect the diagonal, then of course this will be half, right? Okay, but as we just mentioned, in the rectangle, in a square, they do have parallel lines, right? they do have parallel lines. So with one of the sides on the parallel line with the opposite vertex on another parallel line, once again, you can shifting this half area model by a little bit, and you will get another half area model, which I gave a name for it. That is this one. I call it a mountain. Okay. Now if you look at the blue, the black part, it's a mountain, right? So this will be half of the total area. All right. At this moment, I would like to stop here a little bit and ask you another question. Guys, if the black is half, then how about the white area we have here? How about the white area we have? If we know the black is half, right? How about the white one? Yes, very good. It's actually also half. All right. So if I flip the figure by a little bit, that is, well, you see, if we get an upside down mountain, right? Just now I ask you what is this? You all say it's half, right? So this is actually also half. Okay. So if I split a mountain into two, it's a half. Now what if I split the mountain into a lot of more pieces, like this? All right. So I split the mountain into a lot of more pieces. What do you think? It's actually also half, right? It's actually also half. So I call this one the shock tease. So if you have seen the movie The Shock, right? I see the shock tease, they do indeed looks like this. So you can also remember it as the shock tease, that this is half. Right, this is also half. Okay, all right. So this is also half. Now what else we can have is we can make our diagram a little bit more complicated, right? That is, well, if I flip this figure by a little bit, a bit more. So guys, is this a half? This is naturally a half, right? This is naturally a half. Okay, now we can change it a little bit more. That is, I now split this horizontal mountain into smaller pieces as well. 2 pieces, for example. Is this half? Is this half? Yes, actually they're all the same, right? Actually they're all the same. It's also half. Okay. Now, based on this figure, actually, I can apply what we have done earlier. That is, do the shifting of the triangles, right? So based on this, if I draw some parallel lines, you see, I can shift my vertex along the parallel line into maybe any point inside the rectangle, right? So now what I'll get is something that looks like this. Okay, now if I ask you, is this half? Is this half? Guys, what would you say? This is actually also half, right? This is actually also half. So there are a lot of different ways to think of this. One simple way is, well, you cut into 2 smaller ones. You'll see that the black is half on the left, is half on the right. So if you combine together, that would be half half again, right? So this is also half. Okay, so this is also half. Now, if I have, actually, let me stop here. This is saying if I point randomly inside the parallelogram or the rectangle, I randomly point inside the parallelogram and the rectangle. I connect this point. I connect this point to all four vertices. I can definitely create a half area model. So, well, here I cannot invite you. Now, normally I like to invite people to help me a little bit on the stage, but here I cannot invite you. So let me just draw it. Right. So a parallelogram. Okay. I just randomly point a point inside the parallelogram. Right. So I randomly point a point inside the parallelogram. I now connect all four vertices to this point. All four vertices to this point. It looks like an envelope somehow. All right, but yeah, let's just say this. Okay, so and then I just take, all I need to do is just take the opposite, and then it will be a half. Okay, yeah. Okay, now just now I said intentionally, I said, well, if I randomly point inside this, right? Now what if I accidentally made a mistake? I point it outside of this. Well, so actually, even if I point it outside of this, right, it's still the same. Because if you look at the red parallel lines here, right, based on what we did in topic 17, we can move the center vertex along the parallel line, and the area will never change, right? So that is saying if I move my center vertex to somewhere out here, well, do I still get a parallel? Do I still get a half area model? The answer is once again yes. The left plus the right will still be half of the parallelogram. Okay. So even if I accidentally point a point outside of the figure, still I connect it to all the four vertices, I can still get a half area model. Right? So, well, actually, half area model, I still could remember, right? My class had a very, very fun lesson when we learned the half area model, because they all know it's just half of the total, right? Now, of course, before I take a look at the question, for all the half area model of the rectangle, they are here, okay? And more importantly, there are actually also some half area model of the trapeziums that will be tested. Okay? So it would be great that if you can remember some of the half area model of the trapeziums. But one thing, as you can see here, that is they all somehow related. Yes, of course, Wanxuan, you were in there. Oh, Wanxuan, I forgot about everything. Right? So actually, for the trapezium, all the half area model are related to the midpoints. Okay. So where is the half area model? We can actually quickly finish this question where I'll just give everybody, I just give everybody like 10 seconds, right, to find out what is the area of ABCD. You are given that the shaded area is 242. What is the area of the ABCD? What will be the area of the ABCD? Let's see. let's see. Four A4, yes, very good. Why is 4A4? Because we can tell that the shaded is actually half of the ABCD, right? Okay, now you're almost done because you know the area of ABCD, we're asking for the side length. So just ask yourself, which number times itself will give you 484? And that will be your final answer, right? So to find out this, I highly recommend you to just remember the number, which is 22. Okay, it would be great if we can remember 1 square, 2 square, all the way to 25 square. All right, it would be great. It would be great. Right, but if you don't know, just do a run an estimation. You see, this is very close to 400, right? But you know that 400 is 20 square, right? And then we can take a look at the ones digit. Which ones digit square will give you a 4? 2 times 2, 22 times 22 will end with 4. Right? 28 times 28 will end with 4. These are the only two possibilities. But since it's very close to 20 square, 400, so you can just guess that it is 22 square. Okay? All right, so this is example 1, and we only have one question left. And actually, if you take a look at the guided practice, it is also like just one step, right? The shaded area, 64 divided by 2, 32. Okay? So get yourself familiar with the half area model. Some of the questions should take you less than 10 seconds to solve. Okay, it will save you a lot of time while you are in the competition. Okay, same here, exactly the same here. All right, so the second half is called, yes, this is the last topic we're doing today. All right, so the second area, the second part is, here I'm gonna tell you what kind of situation you should think about this. Right? It's just experience. So whenever you see a figure and another figure where they share the same vertex, so you see here they share the same vertex A, right? Where they share the same vertex. Now here is the idea that we should use your half is my half. Okay, so let's start with a simpler question. Okay, simple example. Let's just say, I have some candies. And you also have some candies. Now I don't know how many candies you have. I also don't know how many candies I have. But when we take out half, each of us take out half of the candies that we have, and we counted, we realize that we have same number taken out, right? So if the half is the same, half of your candy is same as half of my candy, then that basically means your candy, the number of candies you have, is same as the number of candies I have. Right. So this is the idea of your half is my half, or your half might be slightly bigger than my half, but still I can find it out based on the halves, right? So whenever we see this, a stand up, a right up figure as well as a slanted figure, you can try to construct half model. How? You have a point inside the figure. Just now I have told you before, right? How did I do the thing and construct half model? What I did is I randomly point a point inside it and connect to all the 4 vertices, right? So actually it's same here for you. You have a point inside it, you connect it to all the 4 vertices. Now here you are only missing 1. And where's the half model? The opposite 2 parts will be the half model. Okay. All right, so here's the half order. Now, what do we know? We know that area of AEFG is 2023, right? So we can get, and the area of ABCD is 1729. But actually, more importantly is, take a look at the blue part. It's actually a half of the smaller square. So the blue triangle is actually half of the small square. So we know that the blue will be equal to 1729 over 2. It's half of the small square over 2, right? And we also know that blue plus the red is half of the bigger square, AEFG, 2023 over 2. So if you want to know what is the area of the red one, which is what we are looking for, the red square will just be this one minus this one, 2023 over 2 minus 1729 over 2. Right? I'm lazy doing the calculation, so let me just copy the answer. That will be 147. Hey, that's a wonder. All right. So yes, so this would be our last topic in the geometry. Of course, I have skipped a lot of things that you might have seen. I didn't go through the topic 14 in details. But don't say that the topic 14 is simple, so we don't do that. Topic 14 is actually the most difficult one, right? So I highly recommend you to spend a lot of time on that topic, and it's not only difficult, but it's also important. Okay, so guys, that will, before we go, do one last run of rating for this question, and I'll review the answer of a question that I asked you at the very beginning of today's lesson. One, okay. So we have one, 4, 3.5, 3. Okay, so yeah, why don't we just go with a middle one, right? So maybe 3 or 3.5, 3. Let's go with 3. Okay. Now, yes, I forgot that I have one question I said earlier. And you know what? Let's do a vote. At the very beginning, I said my goal today is to turn your brain from Wednesday to Thursday. Guys, have I successfully did that? Have I turned the brain from Wednesday to Thursday? How many of you think yes? Say no. All right, good. Kind of. All right, but you know what's gonna feeling in the empty part after your brain cell died? After your brain cell died, you know what's gonna feel in the empty part? I went back to Thursday. That would be great. All right. What's filled in the empty part would be the priceless knowledge you have learned today. All right, so guys, that will be all we have, and yes, it's knowledge, not air. Okay, knowledge. All right, so guys, that's all. Okay, so yes, we will have one last lesson tomorrow, same time, 2 p.m. and we will also have a mock test later this week. Okay, so if you got time, you want to try how much you have learned, go take the mock test. Hopefully you have actually learned a lot during this week. Okay, all right, so guys, that will be all we have for today. Yes, that will be all we have for today. So yes, I guess I'll just see you again tomorrow. Okay. Bye bye. Yes, or some says fill in with mass, also reasonable. Maybe it's also fill in with mass. Okay, bye bye. The mock test will not be here, but you can register for the mock test. How to see the mock test? Please contact Sync Academy on WhatsApp. I think our teacher have sent out the, yes, okay, she will send out the link in the group chat. So please contact them in the group chat, all right? Or maybe you can message us, all right? Okay, yes. So guys, I'll just see you tomorrow, and bye bye. Okay, let's close this. Oh, it's cheating. Shh. Bye bye.